A static object is an object at rest, so the forces on it must be in equilibrium. For example, consider an object lying on a horizontal surface. It has a weight, and the weight of the object acts down upon the surface. This is balanced by a normal reaction force, which the surface applies to the object. If the object is at rest, it follows that W minus R is equal to 0. Or, just adding R to both sides of this equation, W is equal to R. Or, if you like, forces up equal forces down. Suppose we apply another force to our object, maybe by pulling a string attached to it, creating a tension force. There is now a resultant force, so the object will accelerate to the right. However, this force may be balanced by a frictional force, so the object will remain at rest, and now forces to the right are equal to forces to the left. There is a limit to the strength of the frictional force in any particular circumstance, known as limiting friction. The maximum size of the frictional force between two objects is equal to mu, which is the coefficient of friction, multiplied by R, which is the normal reaction force. So mu is the coefficient of friction, and that is determined by the property of the contact between two surfaces, and R is the normal reaction. If we gradually increase the force pulling the object, eventually it will reach limiting friction. Up until this point, the balance T is equal to F is maintained. So if you pull slightly harder, the frictional force will increase to compensate. But once T is greater than F, then F will stay at a fixed level, at least as far as we're concerned, and the object will accelerate to the right.